Let's check the image of negative 3 and 2 under the rotation of theta being negative 45 degrees about the origin. This hints the idea of an angle which is a central angle, as we have here the point of rotation at the origin. One thing is for sure here, that the location of our point would have its initial side. So in this case, we have negative 3 and 2, considering that each grid here is 1, negative 3 and then 2. This is our point, negative 3 and 2. So if we're going to draw a line that would contain that specific point, okay, and add here your arrowhead, this would be your initial side. And the rotation, or the image of the rotation, is somewhere on the terminal side. Now, but take note, the angle here is actually negative 45, so the movement is clockwise. That would mean, if we're going to talk about this here, until you reach a 45 degrees, okay? So, until you reach a 45 degrees, the point or the image is on that terminal side. Later, let's verify the location of that in the Cartesian plane. We do have a formula for the rotation. The rotation is given as the product of two matrices. You have cosine theta, sine theta, negative sine theta, positive cosine theta, times your components x sub 1 and x sub 2. Sometimes we use x and y as they are also components of points in the Cartesian plane. But just to be consistent with the rest, let's have x sub 1 and x sub 2. So our x here, we'll have the components of negative 3 and 2. This will be your x sub 1, and this is actually your x sub 2. And our theta is negative 45 degrees. So we're going to plug that in on our formula here to determine the image of the point under the given rotation. So we'll have here the rotation of theta is identified as the cosine of negative 45 degrees, sine of negative 45 degrees, negative sine of 45 degrees, and positive cosine 45 degrees, negative 45 rather, times negative 3 and 2 as your components for your x. So simply, first, try to come up with the result for this. So you have cosine of negative 45. On our unit circle, it's somewhere actually here. So 45. So it's on the fourth quadrant. Let me erase that so that we will not be confused with the result. So cosine of negative 45 degrees is actually square root of 2. Again, let me change the color. Square root of 2 over 2. For sine, is also square root of 2 over 2. But since it's on the fourth quadrant, you have negative here. For this one, so negative of the negative square root of 2 over 2. And you have here square root of 2 over 2. To be multiplied by negative 3 and 2. Okay? To continue, you have your square root of 2 over 2, negative square root of 2 over 2, now positive square root of 2 over 2, positive square root of 2 over 2, times negative 3 and 2. So the rotation now of the angle is identified. Take note, this is defined. You will have your 2 by 2 matrix times 2 by 1. So we're expecting a result of a 2 by 1 matrix, which could be stand in this manner, still considered to be a point. Okay? So we will have here, to complete this, so you have square root of 2 over 2 times negative 3 plus square root of 2 over 2 times 2. Okay? Next, the other one is negative square root of 2 over 2 times negative 3 plus square root of 2 over 2 times 2. This would mean that we will have here the point negative 3 square root of 2 over 2 plus square root of 2. Okay, you can have something like that. Or you can just not simplify the 2 here. So you will have 2 square root of 2 over 2 so that we can actually combine this later. Similarly, you have positive 3 square root of 2 over 2, then plus 2 square root of 2 over 2. Again, I did not simplify this because I can still combine them, okay, into this form. So negative 3 plus 2 is negative 1 square root of 2 over 2. 3 plus 2 is 5 square root of 2 over 2. So we actually have a point, negative square root of 2 over 2, and 5 square root of 2 over 2. This is the rotation of the point about the origin on theta negative 45 degrees. If you would like to verify that in the Cartesian plane, let's try to come up with its approximation. We have here negative square root of 2, then divide by 2. So you will have approximately, again this is approximation, so let's have approximately 0.71. Okay? And for the other one, you have 5 square root of 2, then divide by 2, it's approximately 3.54. Let's show this on our Cartesian plane. By the way, this is negative, right? Negative square root of 2 over 2 is negative 0.71. So here, negative 0.71 is actually almost 1. So we did not reach 1 here. I'm talking about this area. And then 3.54 is 3.5. So if we're going to have here 3 and 4 somewhere in the middle, so 0.71 in here. This would be our image. In short, the terminal side of our angle here is the side containing that. So to make it better, our angle here of 45 degrees actually ended up until this point here. So this is just our rotation, negative 45 degrees. As you can see, the rotation is clockwise. Okay, that's why the location for the image is here. Okay, now that's how we solve for the image of this given item. Thank you very much for watching.